Hello, my name is Krupesh Kilusia from Vishwakarma University in Masters of Computer Application. Today, me and my friends are going to present the topic Transaction Management in Database. So, I will introduce the importance of transaction management in ensuring data integrity and consistency in databases. So, there are key concepts which we are going to see. The ACID properties, the A stands for atomicity, C stands for consistency, and I stand for isolation. The D stand for durability. So there are many other concepts which are concurrency control and recovery mechanism, which we will see. So let's see the what is transaction management. The definition of transaction as a sequence of database operations. The importance of transaction in maintaining data integrity. There are many real-world examples of transaction management, like bank fund transfer. So the next topic, acid properties, is going to explain by our group member, Mohsin Ladaf.
Asset property override atomicity ensures all operations in a transaction are completed. Otherwise, none are. Consistency guarantees the database remain, remains in a valid state before and after the transaction. Isolation ensures concurrent transactions do not interfere with each other. Durability. Once a transaction is committed, changes are permanent. Transaction states. Active state. Definition. Is this the initial state of a transaction? During this during this phase, the transaction is actively executing its operation, such as reading from or uh, writing to the databases. Transaction. If all operation execute successfully, the transaction moves to the partially committed state. If an error occurs, it transaction to the failed state, partially committed state. Definition. After, after the transaction executes its final operations, it enters this state. At this point, the changes are stored in the buffer memory but are not yet permanent in the database. Transition. If the system successfully writes the changes to the databases, the transaction moves to the committed state. If a failure occurs during this process, it transaction to the failed state, committed state. Definition. In this state, all operations of the transaction have been successfully executed and the changes are permanently saved in the databases. The transaction is now complete. Transaction. Once committed, the transaction cannot be undone. It has reached, reached its final state. Fa- Failed state. Definition. A transaction enters this state if any of its operations fail during execution or if it in encounters issues during the commit process. Transition. From the failed state, the transaction must be rolled back to maintain databases consist, consistency. It then moves to the aborted state. Fifth, abort state. Definition. After a transaction fails, it enters the ab- aborted state. In these phases, the database's recovery system ensures that all changes made by the transaction are undone, restoring the databases to its previous consistent state. Transaction. Once aborted, the transaction can either be restarted or terminated depending on the system's recovery procedures.
Hello everyone, I would like to thank Mohsin for handing it over to me. My name is Atasham and I will be talking about a very important concept in SQL, transition management along with transition loss. Let's start with the basics. A transition in SQL refers to a sequence of one or more SQL operations that are executed as a single unit of work. This transition ensures that either all operations are completed successfully or none at all. This helps maintain the accuracy, consistency and reliability of the database. There are four key commands used to control transaction. First, begin. This is used to start a new transaction. Second, commit. This command is used to permanently save all the changes made during the transaction. Third, rollback. This undoes changes if an error occurs during the database back to its previous state. Fourth, save point. This allows you to set a point within a transaction that you can roll back to without cancelling the whole transaction. For example, if you are inserting data into a table and something goes wrong midway, maybe a constant is violated, rollback will undo all the changes made during the transition to keep the data clean and consistent. Now coming to transaction log. A transaction log is a special file that records all the changes made to the database. It includes details like which transaction was performed, at what time, what kind of operation it was, like insert, update, delete, and the status of the transaction. So why is this important? Because transaction logs play a critical role in data recovery. If the system crashes or any failure happens, the database can use the logs to restore data to a consistent state. It also helps in auditing and tracking changes made over time. In short, transition management ensures that your database behaves reliably and predictably, and transition log acts like a backup trail that helps in recovery and tracking. That's all from my side. Now I will to hand it over to Yash, who will continue with the next topic. Thank you all for the listening.
In this slide, we are looking at the problems that arise when multiple transactions are executed concurrently. These issues can compromise data integrity if not managed. The most common problems include lost updates. When two transactions read the same data and update it simultaneously, one update can override the other without being noticed. Second problem is dirty reads. This happens when a transaction reads the data that has been modified by another transaction but not yet committed. If the transaction goes back, the read data becomes invalid. Non-repeatable reads. A transaction reads the same data twice and finds different values between another transaction modified the data in between the reads. Phantom reads. New rows are added or removed by another transaction between two reads of the same query, leading to inconsistent results. All these issues led to inconsistent data, which is why managing concurrency is essential in transaction processing. We will see how techniques like locking scheduling help addresses these problems in upcoming slides. A scheduler plays a crucial role in database transaction management. It acts as a coordinator, handling the exception of multiple transactions to ensure they occur in a controlled and consistent way. As you can see in the diagram, multiple transactions like transaction 1, 2, and 3 are directed through the scheduler before they reach the database. This ensures that the operations do not interfere with each other. Main goals of the scheduler are to maintain serializability which means that the outcome of executing transactions concurrently is the same as if they were executed one after the another. To prevent conflicts such as lost updates or inconsistent reads that arise from concurrent operations, without a scheduler, transaction could execute in arbitrary orders, leading to data anomalies and inconsistency. So it ensures smooth, safe, and predictable transaction execution. In summary, transaction management is key to maintaining the accuracy and reliability of a database. It makes sure that operation either complete fully or not at all, preserving data integrity through ACID properties. We have looked at the different states a transaction can go from active to committed or aborted, and the SQL commands used to manage them like begin, commit, rollback, and save point. Transaction logs help with the recovery and durability by keeping a record of all changes. We also explored how concurrency control through methods like locking and time stepping help prevents issues like loss of dates and dirty reads. When multiple users are accessing the database at the same time, altogether, these concepts are crucial for building database systems that are reliable, consistent, and efficient in real world applications. Thank you so much.